All right, so today we're starting our unit on circles, and it's going to be quite a bit different than what you've done in the past because we're finally going to get away from area, perimeter, radius, and diameter. We're going to actually do some other things with circles because believe it or not, those are not the only things that circles do in the world of math. It's just what you've seen repeated probably the last 5 years in your math class. So today might feel a little bit heavy because there is a lot of new language. There is a lot of new diagrams and visuals and things to wrap your head around. So be patient with yourself as you're kind of figuring out what all this new stuff means and how you can use it appropriately. It's going to take a little bit of time. So today, let's start with vocabulary. There's a lot of pictures on here with information. It's not something I expect you to memorize by the end of the video. This is something that you're going to refer back to over and over and over again today and even going forward. You're going to probably be using these notes repeatedly as we go through this chapter. So plan on referring back to this section multiple times. So to start with, we'll just go with what you know, right? The center is point A. It's the center of the circle. A radius goes from the center to the edge. So AD, AC, AB, those are all radiuses. A diameter goes from one edge of the circle to the other edge of the circle. It goes through the center. That's what makes it a diameter. A chord is a line that goes from an edge to an edge. So like BE right here is a chord. The diameter is also a chord. It goes edge to edge, but it's a special chord because it goes through the center, so it gets its own name. But any other chord just goes from one side of the circle to the other. A tangent line is a line outside the circle, and what makes it special is it touches the circle at exactly one point. That's called the point of tangency. So in this picture, it would be point B. And this line F is only going to touch that circle in one specific point. An inscribed angle is an angle that is inside the circle, and all of the corners of the angle are on sides of the circle. So like if I start at C and then I go to B and then I go to E, that's an inscribed angle. So any angle that starts and ends on the sides is an inscribed angle. A central angle starts and ends on the sides of the triangle, but the midpoint of that angle, instead of going all the way to the other side and then back, it goes to the center of the circle and then back to an edge. So that's a big difference today, inscribed and central angles. Inscribed goes all the way across, central just goes to the center. That's why it's called the central angle. And then an arc. An arc is just a measurement of the edge of the circle. We call that the arc of the circle because it's arced, right? So like DC is an arc. BE is an arc. And you'll notice that on the diagram, when it writes arc BD, it doesn't just have a line above BD, it has this arc above it so that you know the difference between the line BD and the arc BD. Those are two different measurements. All right, so things that you need to know about these new terms. An arc is measured in degrees. That's one of the ways we measure an arc. We can also measure the length of an arc, like when we find the perimeter, but a lot of what we're going to be doing in this chapter is we're going to be measuring using angles. So the arc measurement in degrees matches the central angle. So if this central angle is A, and notice that it starts at this point and ends at this point, now that central angle that's connected to those 2 points is equal to the arc that connects those 2 points. So if this is an 80, no, that's bigger than 80 degrees, isn't it? If this is a 100-degree angle, then this arc would be a 100-degree arc. That's how we would label those parts. So the measurement of the arc matches the central angle, all right? Now, right next to it, we're going to go sideways. We're going to skip over to this one because there is a relationship between a central angle, an arc, and the inscribed angle. So if I took that same arc that we used before, if I took this arc along the outside right here and connected it with inscribed angle. So if this arc was connected to this angle right here. So this angle measurement, A, let's call it, I don't know, 60 degrees. If that angle is 60 degrees, the arc of that angle is not 60 degrees because I'm not connected to the center. I'm not going from my endpoints of my arc to the center. I'm going from the endpoints of my arc to another point on the circle. And I'm making an inscribed angle. So the inscribed angle is half of the arc. So that would mean the arc is 120 degrees. The inscribed angle is half of that. And if I were to draw a central angle also, the central angle would match the arc. The inscribed angle would be half of the arc. Now, here's my favorite use of this rule, okay? Let's say that this arc right here, let's give it a measurement. Let's say that this measurement is 100 degrees, okay? Now, if I were to just pick a point somewhere on the circle, let's call this P over here, and I connect my arc to that point, then I just made an angle, an inscribed angle, and it's half of that 100 degrees, so that's 50 degrees. Now, if I go somewhere else and I put a point, if I put a point right here and I connect it to my arc, I'm still using that same 100-degree arc, but my point, my new point, I'll call it M, is somewhere different than point P. But what's cool about those angles is they are both 50 degrees. So any point on this circle, if I connect it to the endpoints of my arc, I'm going to end up with an angle that is 50 degrees. So it doesn't matter where I move this point, my angle is always the same. It's always 50. So that's going to be a powerful tool that we use today. Opposite angles. So if you have what's called an inscribed quadrilateral, so a quadrilateral has 4 sides. I've got the purple side, the red side, the blue side, and let's go, I already used purple, so we'll go with, nope, that looks too much like red. Where's my other colors? There we go, green. We'll go the green side. Those 4 sides make a quadrilateral that's inscribed to the circle. It's connected to the sides of the circle, and it's inside the circle. Now, what's cool about opposite angles, so when I say opposite angles, I mean angle C and angle D. If I add those together, they equal 180 degrees. Same thing if I add A and B together. Those opposite angles are going to add up to be 180 degrees. So powerful tool there. And we already talked about this next one. If 2 inscribed angles intercept the same arc, then the angles are congruent. So if you notice, both of these angle A's right here start here and end here. So they're both connected to this arc, which means they have the same angle. Those both have the same angle, and it's half of whatever this is out here. Okay, so let's use some of this to try and do a little bit of math. And again, be patient with yourself. There's a lot of rules that you're trying to remember. There's a lot of things that you have to refer back to. And it's going to take a little while to get the hang of it. So example A, I've got an inscribed angle. It doesn't go to the center. It goes across the circle to the other side. And it has a measurement of 48 degrees. And it wants me to find the measurement of the arc that's connected to that inscribed angle. Well, the rule up above tells me that this angle is half of this arc. So if my little angle is 48 degrees, then this arc on the outside is double that. It's 96 degrees, okay? Example B, I've got, let's see, sometimes I'll tell you what, colored pencils are going to make your life a lot easier on these circle assignments. So I've got this 25 degrees right here, and it's made up by these two lines. That inscribed angle is connected to this arc. Now, angle B stops and starts at the same arc. So my left spot and my right spot are the same as my blue inscribed angle. So that means my angle is the same. So B is going to be 25 degrees. Example C, I've got an inscribed quadrilateral, and I learned that opposite angles add up to 180 degrees. So that means 85 plus C is going to equal 180. So I just take 180, I minus 85 degrees, and that gives me angle C, which is going to be 95 degrees. So this angle would be 95 degrees. Let's go to D. This is something that wasn't mentioned up above, but this is a really cool thing that you should probably take note of because it's going to come up a lot in problems going forward. Notice that I've got this angle D. It's an inscribed angle. The corner of the angle is on the circle, and the sides connect to the circle. So that's my inscribed angle. But these connect to a special chord. They connect to the diameter of the circle. Now, if you remember that this angle is half of whatever this arc is, and if you imagine a circle, and if I'm going from one side of the diameter to the other side of the diameter, I'm going halfway around the circle. Well, a circle is 360 degrees total. If I go all the way around, that's 360 degrees, right? Well, I'm not going all the way around. I'm only going halfway around. So this red arc right here is half of 360 degrees. So it's 180 degrees. And my blue angle that I've drawn in there that's connected to my diameter is half of that. So D is 90 degrees. So I've got my inscribed angle that ends on a diameter. So I know that this distance is a 180 degree arc. And so that means anytime I have an inscribed angle connected to a diameter, my angle's 90 degrees. So if I go over to here to example E, and I can put a point anywhere. If I connect that to this diameter, then what I've just made is 90 degrees. If I put my point over here and connect it to my diameter, I just made another 90 degree angle. So any inscribed angle that's connected to a diameter gives you 90 degrees. All right, E, I'm looking for little e, and one edge of little e, this side right here, goes through the diameter. The other side, this one right here, connects to the side of the circle, and I'm looking for the inscribed angle. Well, that inscribed angle is connected to this arc on the outside. So if I can find this angle arc, or this arc's measurement, then I can find E. Well, let's see, what do I know? I know that a diameter goes halfway around the circle. So this blue arc up here, that's a 180 degree arc. And it tells me over here on the left, this green arc right here is 75 degrees, which means my pink arc is whatever's left over. So if I take 360 minus 180 and then minus 75, I get 180 minus 75, which gives me 105. So this arc right here, this pink part, is 105 degrees, which means that the angle that makes it is half that big. So my angle E is what? 56.5 degrees. Is that right? It's going to be, or 57.5. My bad, not 56.5. It's 57.5 degrees. So it's going to be half of 105. Okay, let's go to problem F. Problem F, I'm going to zoom in a little bit to try and see something a little bit, just a little bit closer up, because there's a lot going on in a small amount of space. So I'm looking for this blue central angle right here. Now, this central angle, if I follow these lines, they go from here to here, which means they are connected to this blue arc. Well, this other measurement that it gives me, this 53-degree angle, is also connected to that blue arc, but the red one is an inscribed angle, and the blue one is a central angle. And if you remember from up here, if my inscribed angle is A, my central angle is the same, this angle right here. I guess this angle right here is twice that, right? It's this relationship right here. They're kind of mixed together, that the central angle matches the arc, and the arc is twice as big as the inscribed angle. So if this red angle is 53 degrees, then that means this arc is twice that big. So it's 106 degrees. Well, if that's 106 degrees, then my central angle, my blue angle, is also 106 degrees. Because the blue angle matches the arc, the red angle is half of the arc. That's something you're going to have to get used to, the difference between the two. All right? Okay. All sorts of stuff going on in these problems, okay? So use what you've learned in the past. Use what you learned today. Get some colored pencils and start trying to find connections between these different shapes and the circles that they go with. Again, I think one of the best things you can do, like number 2, if it gives you an angle, one of the best things you can do is kind of color code what makes that angle. Well, these two sides make that angle, which are connected to this arc. And if that angle's 53 degrees, that tells me something about the arc. Well, that arc is also connected to these two blue lines. So that tells me something else about the blue lines and the angle that makes the blue lines. So if you kind of work your way, use some colors to kind of help you organize your thoughts and organize the picture, because there's some of these have a lot of things going on with numbers and letters all over the place, and it can be hard to keep track of what information goes where. So best of luck. Come see me when you need help.